In 2026, the global data sphere is expected to hit 200 zettabytes. To put that into perspective, if you store that on standard 22 terabyte enterprise hard drives and stack them, you would need 9 billion drives. The resulting tower could reach 147,000 miles into space, over 60% of the way to the moon. But the real story isn't the stack of hard drives, it's the tax on the movement. Over 30 years, the network tax has fundamentally changed. We've moved from building miles of glass in the 90s to managing microseconds of logic in the AI era. Today, we move from a world where networking was support plumbing to a world where the network is the computer. In 1999, the network was a physical asset. If fiber was the digital highway, then Cisco Systems was the only company selling the engines. It was the era of pure CapEx. Companies like WorldCom were driven by a single, seductive myth, that internet traffic was doubling every 100 days. To prepare for this, they over-engineered everything. The result was an infrastructure paradox. We essentially built a 10-foot wide water main pipe, but at the time, the world was only consuming a garden hose worth of water. Because they owned the market of the valves and the pumps of this pipe, Cisco stock became the ultimate proxy for the internet itself. In March of 2000, Cisco became the most valuable company in the world, with a market capitalization of $550 billion. Their stock price had climbed nearly 100,000% since their IPO. At its peak, investors were paying for a century of future profits up front. Then came the crash. Cisco's stock price tanked, losing 80% of its value, and they were forced to write off $2.2 billion in excess inventory. But here's the secret of the cloud. That 10-foot pipe didn't go to waste. Because the infrastructure was already paid for and sitting idle, the cost of moving data plummeted. That extra capacity became the growth engine for the cloud. Without the waste for overbuild of the 90s, the cheap, high-bandwidth world of AWS and Netflix would have become economically impossible. By 2006, the world was done with route miles. We moved from buying the pipe to renting the water. This was the OpEx revolution. But cloud providers like AWS didn't just sell compute. They sold economic arbitrage, the Hotel California model. In the cloud, the network acts as a toll road. Cloud providers realized that data has mass, a concept we call data gravity. They built a pricing model that mimics the Hotel California. You can check in anytime you like, but you can never leave. Ingress is free. Moving data into the cloud is free. They want your data to check in because it is sticky. Once your database hits 100 terabytes, the gravity of that mass pulls your compute, your analytics, and your machine learning tools towards it. Egress is the toll. The moment you want to move that data out to a competitor or to your own on-premise servers, you hit the toll booth. The industry standard for egress is roughly 9 cents per gigabyte. To a developer, it's invisible. To an enterprise, it's an anchor. A 2021 Cloudflare report showed that while the cost of wholesale fiber has dropped, cloud egress fees remain virtually stagnant. They estimated that AWS marks up the price of bandwidth by up to 8,000% over wholesale costs. If a media company stores a 1 petabyte archive and users stream it once, the egress bill is $90,000. This retention fee ensures your applications stay locked within their ecosystem. This created a north-south economy. Traffic flowed from the north, or the cloud, to the south, the user. Because the data center was effectively a cold storage vault, the only metric that mattered was the throughput to the internet. Inside the buildings, servers were quiet. They were like independent contractors in a cubicle farm. They all looked at their boss, the user, but they never spoke to their neighbor. In 2014, containerization changed everything. We stopped building monoliths and started building microservices. Suddenly, an application was 1,000 tiny pieces talking to each other constantly. This exploded east-west traffic. Here's the secret economic driver of this revolution. In the cloud, east-west traffic is generally free. While the providers charge a fortune to send the data south to the users for egress, they often charge $0 to move data sideways through the same zone. This tax-free environment allowed developers to build complex collective organisms without the financial friction of the toll road. It accelerated the adoption of containers because the network costs of internal chowder were effectively subsidized. But this pattern broke existing laws of physics. For 20 years, we used a three-tier hierarchical design that looked like a tree. Access switches at the bottom, aggregation in the middle, and the core at the top. This design was perfect for north-south traffic, but in a containerized world, data had to travel all the way up the tree to the core and back down just to talk to a neighbor. This created choke points and massive latency. The tree was getting strangled by its own branches. To fix this, engineers threw away the tree and built a fabric, the leaf spine architecture. Every leaf switch is connected to every spine switch. Now, every server is exactly 2 hops from any other server. There is no up or down. There is only a cross. This architectural pivot was the only way to support the massive volume of east-west traffic that modern apps require. There is a massive misconception that because networking moved to software, the hardware became a commodity. It's actually the opposite. This is the physical paradox. Because the software was now talking 10 times more than it had before, the physical wires had to handle 10 times the load. The physical wires became the hard floor that the software ceiling relied on. If the container era invented the collective, AI is the great enforcer. In an AI data center, the network is no longer support plumbing. It is the industrial assembly line. The unit of economic consumption has changed. We don't talk about gigabytes. We talk about tokens and job completion time, or JCT. In training, the only metric that matters is job completion time. You have a $500 million cluster of GPUs that must synchronize every few milliseconds. Meta's research on their Llama 3 training runs, utilizing two 24,000 GPU clusters, highlighted a terrifying reality. AI training is incredibly fragile. In a standard network, 1% packet loss is a minor nuisance. In an AI cluster, it is a catastrophe. Because GPUs operate in a synchronous loop, a single drop packet creates a straggler. Meta found that even a 0.01% packet loss can slash GPU utilization by over 10%. If your packet loss hits 1%, your $500 million cluster sees its performance drop by 30 to 50%. You are effectively burning $250 million of capital investment because your networking isn't lossless. This is why the industry has pivoted towards high-performance, lossless Ethernet using Rocky v2. Once a model is trained, the revenue unit is the token. But the economics of a token are fundamentally different from a web page. A web page is a static asset. A token is a computed product. Let's look at the token tax. In a modern LLM, you might charge a user 1 cent per 1,000 tokens. That looks like software margin, but as we move towards AI agents, the network becomes a variable manufacturing cost. An agent is essentially a container with a brain. When you ask an agent to plan a 7-day trip to Tokyo, or research a competitor, it doesn't just generate one response. It initiates a chain of thought loop. It might call a search tool, then a weather API, then a flight database. Each of these steps involves an internal inference loop. To give you 1,000 tokens of a final answer, an agent might generate 5,000 to 10,000 internal tokens of reasoning and a verification before the user sees a single word. Each thought in that chain moves across the leaf spine fabric. Here is the economic crunch. In this agentic loop, network latency is directly subtracted from your gross margin. If your internal east-west fabric is slow, the agent waits between reasoning steps. If that internal latency adds 100 milliseconds per reasoning step, and the agent needs 20 steps to solve a problem, you've just added 2 seconds of delay. In the world of high-frequency AI, that delay makes the agent feel dumb or broken. But worse, every millisecond a $40,000 GPU is active, but waiting on a network handshake between agents is a millisecond where it is consuming 700 watts of power, but generating zero revenue. We are seeing a recursive traffic explosion. The tax-free east-west traffic that fueled the container era is now the most valuable real estate in the data center. If you can't move those tokens across the fabric instantaneously, your cost to serve skyrockets, and your business model collapses. The network is no longer a utility. It is the efficiency engine that determines if your AI business is profitable or just a way to subsidize your users' compute costs. For decades, we've heard the marketing slogan that the network is the computer. But as we've seen, that was never actually true. The network was never the computer. The network is the arbitrage. It is the difference between a profitable token and a wasted watt. It is the difference between a microservice that scales and a monolith that suffocates. It is the invisible hand that determines where the data lives, how much it costs to move, and who gets to keep the margin. As that 147,000 mile stack of 22 terabyte hard drives continues to grow, reaching further into the void, the challenge isn't how to store it. The challenge is the physics of the tax. We have moved from an era where we overbuilt miles of glass, to an era where we metered every drop of data, to an era where every single drop packet can bankrupt a training run. We are no longer just moving packets. We are moving at the velocity of value itself. The wires in the ceiling aren't just plumbing. They are the clock speed of global logic. If the network slows down, the economy of intelligence stops. Understanding these economics isn't just for engineers anymore. It's the roadmap of the next 30 years of digital wealth. I'm Dan, and I'll catch you in the next one.